All right, today is ITS 128, and we are going to cover more on classes, Chapter 9 classes. So let me share my screen here, and I'm gonna not click that button and see how this works this time. I'm trying to think this should be over here. No, maybe it should be right up here. Anyway, here's my, this is where we are, ITS 128. And we are in Chapter 9, which is classes. Now, let's bring up the textbook and see what's there. I wanted to actually show you by example using the assignment that we're doing right now, assignment 12, and how you don't need to do this, but I'd like to explain classes more like what we see here. In the assignment, we actually, it's all about forms. We made we are creating multiple, we're creating a project with multiple classes, but the multiple classes are multiple forms. And so you don't really get the full effect of why we would have another class. So today I'd like just to parse up our project a little bit more, just to demonstrate how we can the concept of a class a little better. So let me go and download my my assignment 12 that I was working on. I go to my Dropbox and go to mine and download my assignment 12. Do I have it here? Here, from last time. And I can open this up and I can copy this onto the desktop. Close this and open this up and open this up. And let me log in. I'll have to log in. All right, let's start this up and see and remind ourselves what this is about. And so we have created forms for each one of these tests. And when you click the first one, it opens up this test here, which performs this test, and we can execute it, and we see it provides us the same answers as before. And then we can exit this and pop out the additions test, same test did before. And we can pop out the precisions test, and this does the double precision, and this is decimal precision. And then I also asked you to put a, I call it a legacy form, or this is one of the previous assignments. It doesn't have to be assignment 7, it can be assignment 6, assignment 5, just to show that. And then quit. And if we look at the assignment, there's actually a couple more things that I want you to do, and I've actually modified it slightly. First of all, let's see, this up here didn't change. But I explained down here a little bit better. Okay, I said, okay, I asked you, instead of a 1-minute video, you can do an in-person demonstration. That's fine. So if you just want to show me. And what I'd like you to show me is that all the buttons work. And the other thing I'd like you to show me is I want you to understand what it is we're doing here with these tests. So when you're doing the divisions test, I want you to show me a test where there's no difference in the two number formats, and that there is a difference. And I want you to tell me which one is correct. So for divisions, that's way, and then for additions, you know, you can show me some parameters or some arguments where it's different and where it's the same and which one's correct. And then also for the double precision and the decimal precision, now you're not going to get times, you know, the amount of time these things take. You're not going to get that to be the same, but you'll get the values, the number of the response values to be exactly the same until you reach a certain point, and then they won't be anymore. So I just want you to show me, you know, that you sort of understand what this is supposed to be demonstrating, and it's the difference, how your results can be different by selecting the wrong number types to when you declare your variables. You know, do you declare them as integers, or do you declare them as doubles or as decimals or whatever? So that's what I'd like you to do. And so for an example, you're probably wondering about an example. Well, let's do some examples here so you can see that. The divisions test here, we see that when we set a max discount percent of 30 and a markup percent of 20 and a nice factor of 30, we get 20 when we use this, when we define our division using double type numbers. When we define it using integer type numbers, we get 0. Well, when you look at what's going on here, let's look at the division test, not the design, the actual code. We are taking a number, and we are taking a number, and another number, and another number. These are 3 numbers that we enter in. This is like 30, 20, 30, or something like that. And we take the 30 and we divide it by 20, and we get a number, and then we multiply that by the 30 again, and we end up with some number that we assign the value discount, and then we display that out. And so there's times when this calculations come out the same. Oh, and then the second time, instead of using double discount, we use integer. So, and we're using an integer markup percent and a byte valued max discount percent, rather than these ones that we used up here. So, when we run this, we see that when we're choosing 30, 20, 30, they're not the same. But how about if we choose 30, 30, 30? You know, well, that's the same. How about if we choose, you know, 50, 50, 25, 10 or something? No, that's different. Well, the 30 and the 30, they were the same, and the 20 and the 0 were not the same. In this case, the 20 is the correct value. The double value would always be the correct value. The integer value might be smaller because with integers you hack off the remainder. Like if it's 25.3 and you put that into an integer, it's only 25. So it hacks off the decimal, and then that can cause, when you do calculations with integers, especially when you're doing divisions, they can end up, you can end up with smaller numbers than are the actual result. For additions, we see that when we're, what this does is this compares taking 0.1 times 10 or 0.1 plus 0.1 plus 0.1 plus 0.1 10 times. So when we do, 10, let's do 5. So 5 times 10 is 50. And if you add 5 plus 5 plus 5 plus 5 plus 5, do that 10 times, both times you end up with 50. But when you do this 0.1 10 times, it doesn't end up quite exactly right. And so in the first case, in this case, you're multiplying 0.1 times 10. Well, it can figure that out. It's just 1. But in the second case, you're taking 0.1 plus 0.1 plus 0.1 plus 0.1, and you do that 10 times. And the fact of the matter is, the computer cannot really store 0.1 exactly as 0.01. Okay, it stores it as a number that's a little tiny bit smaller because because when it converts to base 2, it doesn't convert evenly. So it ends up being a little bit smaller. And when you multiply 0.1 times 10, it does a multiplication algorithm. But when you add 0.1 to itself 10 times, you're actually adding a number that's slightly smaller than 0.1 because that's how it's stored. And after a while, that cascades up. And so if we go to 100, we end up with a bigger number, actually, if you go to 100, it ends up being the same. Now that's strange. I can't really explain that, but if you think about it, it would probably make sense. For 1,000, it's the same. For 10,000, it becomes different. Starts to become different again. All right. So that's the additions test. The precision test here, when you're doing this big number, which is 10 million or some huge number like that, we see there's quite a bit of difference. It looks quite a bit different. If we do 1 million, it's still different. It's got an E in there. If we do 100,000, it's the same. Okay, if we do 100,000 of those computations, let's see what those computations are. Let's do 0, and what do we get? Let's start over again. If we do 1, what do we get? We get 0, 0. Okay, let's do 2. We get 1, 1. Oh, the separate number is how long it takes to compute. 3 is 5, 5. 4 is 14, 14. 5 is 30, 30. 50 is 4025, 40, okay, like that. So 500. But anyway, it ends up being something like 12,000 or something, where we end up getting different. No, not 12,000. How about 120,000? No, not 120,000. How about 150,000? There's the E there, and it's not going to have an E here. Okay. So 150,000, 140,000. That looks like 140,000 is okay. 145,000. No, that's not. Anyway, so that's the point of the actual of choosing this exercise. Back when it was assignment 3, we were talking about number types, and I needed a problem that would demonstrate that if you choose the wrong number types for some particular problems, you could end up with the wrong answer. Anyway, okay, so So now I'd like to show you about classes, how I wanted to, if we, did I have the textbook up here? Yes, I did. A class, creating a class is a way of consolidating like functions or variables and methods that sort of make sense to be associated with each other and designed together. And when you're going to use one, you're going to use the rest of them also. So object-oriented programming is sort of designed for this, and it turns out we use classes all the time. These are classes up here, and they're classes that provide different sorts of things, different sorts of functions, and so on. So so one thing we could do is with these forms here, like let's take this form. Let's take the division test form, which would look like this one. Well, no, let's look at the math division test. Okay, here's the code for division test, and this is all part of the form class, the division test form class. We created an instance of this thing, and with this, there's what they call a code behind file, and that's this, and this is the code that's associated with that, you know, that easily connects to the components and the tools of this that are on this form. I seem to be waiting for it to do something. Okay, but let's say that what we wanted to do is separate out the mathematical stuff, the math functions, or put all these math calculation functions in one class, and we can call that like the math tests class. You know, it's a class of math tests, or maybe we should do something smaller. Let's do division tests. This is divisions test, right? Let's do a divisions test class. Okay, so division tests. Let's call it division tests. And so I'm going to create a new class, and then I'm going to take these functions here that are in this form class, and I'm going to put it over into the divisions class. So to do that, I'm going to right-click. I'm going to create a new class, add a new class, a new item, and I'm going to add a class. And I'm going to call it division test class. Okay, so it comes up and it looks like this. And one problem is that it came up in the wrong namespace. My namespace is Halverson_assignment 12. I want to change that to Halverson_assignment. Oh, jeez. Let me copy it from here. Copy this. Copy. And go over here. And I'm going to change this to, rename it to that. And to rename it, I can go apply. And now it's in the same namespace as this. This namespace is the same as this namespace. So that way, any class I define here will be available to any of these other classes in the same namespace. Okay, so we can start this off, and it gives you this sort of this template here. And one thing we always do is we start by saying whether it's public or private. So let's make this a public class. And so I'm going to call it that. And so with this class, the main thing this class is going to do is it's going to do the division, the division tests. And the division tests hold the max discount percent, the max discount percent variable is associated with this class because that's part of it. So is the markup percent, so is the nice factor. And then there's the two things that do the calculations, and one does an integer, one does the integer versions, and the other one does the double versions. Or yeah, the double version. Okay, so let's start by declaring some fields, and these fields can be the max discount percent, and let's make those private fields, and then we're going to create these other methods that are used to access accessors are called. So private integer is it? Yeah, these are integers. Let's see, are they different? I guess they're different for each class, aren't they? Okay, so this should actually be the first one because the other, okay, I'm just going to continue on. Integer max discount percent. So there's a variable called that. There's a variable called int markup percent. And there's a variable called private single nice factor. And so after we declare these private fields, we have to declare what's called a constructor, which is used to create this class. Now, it turns out we actually don't have to do this anymore. It comes by default. But I'm going to put it in anyway. Put it in anyway. Public, and you can do it. We're going to be doing this because later we're going to create different kind. There can be more than one kind of constructor to create a class. But anyway, we'll get into that later. But let me just say what this is: division test. Vision test. It looks like you just do this, and then I'm gonna create the accessors to set these fields, or to update these fields, or to read these fields if you want to read them back out. And so there'll be a one public int max discount percent, and I'm using a different convention than the textbook does. The textbook would put underscores here. I don't. I use lowercase here and uppercase here. That's, to me, that's a little bit better way to identify that they're exactly the same, that they mean the same thing. Discount percent, and it's an accessor, it's a method. There's a get part, which is used to return the lowercase one, max discount percent. And then you also have the ability to set this variable, and what you do is you do max the lowercase, the private variable max discount percent equals this implied argument, this implied parameter called value. And this is all in your textbook. And so we're going to do one of these for max discount percent, markup, and nice factor. And so the markup, it's also an integer, so we can just this is markup percent. And this one is going to be nice factor. And it's going to be getting and setting this local variable, this local field, private field. Okay, and so this is used to create a new, this is called a constructor, and you use this thing to create a new instance of a division test class or object. And this accessor is used to set the max discount percent or to retrieve it. This is the same for markup percent, and this is for nice factor. And then we have to have something that actually does the computation, and that's a method, a public. And I'm going to have it return a string that has information, has the stuff that you're going to display out. Public string, and I'm going to call it integer division. Integer division. And so it's going to look like this. And so here, this is where the actual calculation goes. So let me go back to here, and integer that would be this. Something like this. Let's see, we don't, that's not that, and I'm not gonna, I don't need this, I'm gonna create a string variable called return, and I'm gonna set that equal to, I'm gonna display out max discount percent is equals, and then I wanna plus max discount percent, and then I want to say return plus equals. I also want to do markup percent. I might as well do markup percent equals plus markup percent, and then I also want to include nice factor equals plus nice factor. And after all that is done, I want to add that to this. And I'm going to do this. Maybe I'll. And then I want to return that. All right, so this is my class. This is all it is. So and division test is a bad name for it. I should name it division test 1 because it's the first division test. So I'm gonna. Let's see, how can I do that? Can I rename it? Let me save it first. And let me see if I can rename this thing. Division, where is it? Oh, here it is. Rename. I'm gonna call it division test 1. 1. And so that rename that, I want to rename this division test 1 also, division test 1. Apply. Oops. Ha. Division test 1. Okay, so I have my class here, division test 1 class, and what this does is this will provide me all of the capability of doing that first division test. It has like 3 containers for the 3 numbers that it needs, and so you just load those up, And then you ask it to execute this integer division method, and it returns this nice thing that tells you the result. Okay. All right. So let's go to form test 1, or this division test design, and I'm going to throw another button on here to test this. So let me do a button, and I'm just going to say on the button it's going to say test division test 1 class, and I can, for the name of it, I can call it BTN test 1. All right, so let me double click on this, and so here's how I use this class. Okay, you ready? All right. First, I want to create a new instance of that class. So I'm going to say, I'm going to create a new instance. I'm going to create a new variable of type division test 1. Division test 1. So that's the name of this variable, and the name of the variable, I'm going to name it, I don't know, dumb name, just because I can't think of any other better name. So I'm creating this new variable, and the type of the variable is it's a division test 1 object, and it's going to be a new division test 1. So here we're using the constructor. Okay, and so now I have this new object that's got all the stuff I need to do the test. The first thing I have to do is I have to load up those properties. So I do that by saying dum name dot markup percent. No, the first one is max. Doesn't matter which one's first. Max discount percent equals int parse txt max discount percent txt max discount percent dot text. So that will write the value of max discount percent into the max discount field of this object here called dum name, and that object is a division test 1 type object. And so now let's do a markup percent, and that is going to be equal to int parse txt markup percent dot text. And then we also have to load up a nice factor, and that's going to be equal to single parse txt nice factor dot text. Okay, and then let's declare a string div test out, just to keep it separate. Div test out is equal to dum name dot integer division. So this will execute the integer division method inside dum name, and inside dum name it's got that stuff is in these fields. And so if we look at division test, that method is right here, and it's going to take these 3 fields that you've loaded up using these successors and do the same calculations and display them out and return a string. It's going to return a string here, right out here, into here, and then let's just display this out. message box parentheses dot show parentheses div test out. So that'll just display it out. Test. All right. So let's just run this and see if it works. And let's open this up, and here's that button. And so if we click on the button, look at that. It says max discount percent equals 30, markup percent equals 20, nice factor equals 30, and then this is the result. And if we change this to 40, we see that it actually works. So this is the same as the first one. So it should say, if we execute, the first one says double 40, and that's what this one says here, double 40. If we make this, 15, it says double 80, and this one says double 80. So that is how you take a, how you can, so I've shown you how to create a class, and I've shown you by taking some code that we already have that was in the division test, the division test form. It was code that was inside this form class, and I pulled it out and I created a new class just called division test 1 and put the code in there. And then to use this code, you have to create an instance of this class. And once you do that, you have access to all of these things in here by the name of the object that you declared as being this class, which is right here. We declared this object called dumname, and it's a division test 1. It's division test 1 class, and that's how you do it, just like we do other things. And then this writes into those fields because we've defined these accessors here, these things, and then this causes this method to execute, and it returns a string because that's what we say to do, return a string, and this just displays it out. All right, so that's how you do classes, and I will refer to this lecture later because the last assignment is going to have us do classes. We're going to use the concept of a class for our last assignment. All right, so are there any questions? Okay, so I will see you next time, and thanks for watching.